Okay, in this exercise we are asked to find the limit as x goes to infinity of 2x minus the square root of some expression. Now if you allow x to go to infinity, then 2x will go to infinity minus the square root of infinity plus infinity, which is infinity, and the square root of that is just infinity, and this is indeterminate. You might be tempted to use the fact that for polynomials, if x goes to plus or minus infinity, you may delete or ignore the lower order terms. So for this expression, which is 4x squared plus 3x, you may as well want to ignore the 3x and say, okay, that's the limit of 4x squared. So let's see what happens. See, so this is the limit as x goes to infinity of 2x minus the square root of 4x squared, and of course you've ignored the 3x, and that's going to be the limit as x goes to 0 of 2x minus 2x, and this is supposed to be 0. Of course this is exactly wrong. The reason why this is wrong is that because the whole expression is not a polynomial to start with. And the second thing is that whatever you've ignored here is exactly what's going to make the value of the limit. And let me just give you an example to see what I've just said. Well, this is a very similar example to the one that we have in hand here. It's the limit as x goes to infinity of x minus the square root of some expression. So this is the limit as x goes to infinity, and if you want to ignore the lower order terms, then you're supposed to get a 0 again. But now if you don't, so this is x minus this is x plus 1 square under the square root. So this is the limit of x minus well, this is x plus 1. You don't need the absolute values because x is going to infinity. And the result for this is going to be minus 1. So the result is not 0. And it is obvious that whatever we have just ignored is what has contributed to the value of the limit. Okay, then how do we do this problem? We do it by just multiplying by the conjugate, which is a very usual technique. So this is the limit as x goes to infinity of the expression 2x minus the square root of 4x squared plus 3x, and I'm going to multiply that by the conjugate. And of course I will multiply up and down by the conjugate, so as if I do nothing to the expression. Now I will just do some algebra. So this is equal to the limit as x goes to infinity. In the numerator it will be the square of 2x, so this is 2x squared minus the square of the square root, so this is going to be 4x squared plus 3x, and the denominator will remain as is, which is 2x plus the square root of 4x squared plus 3x. So in the numerator it should read minus 3x divided by 2x plus now the square root of 4x squared plus 3x, and I'm going to take just 2x, let me just say, okay, 4x squared as a common factor. So this is going to be 1 plus 3x divided by 4x squared. So this is equal to the limit as x goes to infinity of minus 3x divided by 2x plus, now 4x squared will come out as the absolute value of 2x, but as x goes to infinity that is positive, so I do not need that. So this is again 2x, and that's the square root of 1 plus 3 divided by 4x. Now I can do some cancellation. So this is the limit as x goes to infinity of minus 3 divided by 2 plus 2 the square root of 1 plus 3 over 4x. Now as x goes to infinity, this is going to go to 0, so that's equal to minus 3 over 4. Well, this is a similar problem to the previous one, except that x is going to minus infinity. Under the square root, x squared is going to dominate, and the reason why it does so is the following. See, let's look at the limit as x goes to minus infinity of x squared plus x plus 1. So this is going to be equal to the limit as x goes to minus infinity, and if I take x squared as a common factor, then I have 1 plus 1 over x plus 1 over x squared here. Now as x goes to minus infinity, this part and this part are going to decline to 0, and then whatever remains is just 1 times x squared. So this is going to dominate, and the limit for that is is minus infinity square, which is plus infinity. So this expression here, now the original expression is just infinity, and now x is going to minus infinity, so this is minus infinity. So this is the form infinity minus infinity, which is indeterminate. Again, the way that we do it is we just multiply by the conjugate. So this is the limit as x goes to minus infinity of the square root of x squared plus x plus 1 plus x. Alright, and we multiply up and down by the conjugate. Okay, and the result is going to be the limit as x goes to minus infinity. In the numerator, it will be the square of the square root, which is x squared plus x plus 1 minus x squared, and in the denominator it will remain as is. So this is x squared plus x plus 1 minus x. Okay, now this is equal to the limit as x goes to minus infinity. In the numerator we will have x plus 1 only, and in the denominator I'm going to take x squared as a common factor. So this is going to be 1 plus 1 over x plus 1 over x squared minus x. Now if I take x squared out, I need the absolute value because x could be negative or positive. In our case, as x goes to minus infinity, then x is certainly negative. So this is the absolute value of x multiplied by 1 plus 1 over x plus 1 over x squared minus x. Now I can release the absolute value with a negative sign added. So this is going to be x plus 1 divided by minus x, the square root of 1 plus 1 over x plus 1 over x squared minus x. I will just divide up and down by x. So this is the limit as x goes to minus infinity. Now this is 1 plus 1 over x as I'm dividing by x, and this is going to be minus the square root of 1 plus 1 over x plus 1 over x squared, and this is minus 1. Now as x goes to infinity, this minus infinity, this is going to go to 0, this is going to 0, and this is going to 0. Whatever remains there is 1 in the numerator, and then I have minus 2 in the denominator, so the answer is just minus half. Okay, here is another similar problem. This is the limit as x goes to infinity of some complex expression. So as x goes to infinity, these two terms will go to infinity, this will go to infinity, so this is infinity minus infinity multiplied by also infinity minus infinity here. So let's just do something about it. I'm going to multiply by the conjugate of this part here, up and down, and see what happens. Now, okay, once we multiply by the conjugate up and down, then it is easy to see that the numerator is going to be this expression, will not change, and then the result of multiplying this by this is simply x power 5 plus 7, which is the square of the first, minus the square of the second, which is x power 5, of course, minus is passed to the 6 also. The denominator will also stay the same. Okay, so the numerator is going to be just 1 for this part here, multiplied by this expression, so that is going to be here. Now the denominator, what I'm going to do to the denominator is that I will just pull x to the 5 as a common factor here. So what remains here is 1 plus 7 divided by x power 5, and I'll do the same thing here, which is x power 5 multiplied by 1 plus 6 divided by x power 5. Now I'm going to pull the x power 5 out, and since it is positive, I do not need absolute values. Okay, so x power 5 comes out as x power 5 over 2 because of the square root, and then here I have 1 plus 7 over x power 5, okay, plus now I will do the same thing to the second expression. So this is x power 5 over 2 multiplied by the square root of 1 plus 6 divided by x power 5. So what I'm going to do next is I will just divide up and down by x power 5 over 2. So the first expression here becomes 1 plus x squared divided by x power 5 over 2 is 1 over x power half, and minus x power half divided by x power 5 over 2 is just nothing but 1 over x squared, and in the denominator it will only be the square roots plus the square root of 1 plus 6x power 6 divided by x power 5. Now as x goes to infinity, what will happen to this is that this will go to 0, this will go to 0, this will go to 0, and this will also go to 0, and the result is the numerator going to be 1, and the denominator it will be the square root of 1 plus the square root of 1, which is 1 plus 1, and this is a half.